The next talk is on interactive structure learning with structural query by committee, presented by Christopher Tosh.
Thank you. This is joint work with Sanjoy Dasgupta at UCSD on interactive learning. So why do we want to do interactive learning? Well, there are a few issues that arise in traditional non-interactive settings. For example, in supervised learning, it's often the case that collecting unlabeled data is very cheap, but collecting the labels associated with that data is orders of magnitude more expensive. So labeling an entire data set is prohibitively expensive in some domains. In unsupervised learning, it's often the case that choosing our initial model to fit is not entirely clear. And even when we do choose a model to fit and we get a reasonable fit, it's not clear how to correct obvious mistakes in that model without throwing everything out and starting over. So previous works have tried to address these problems in each of these settings. In active learning, people have tried to approach the supervised learning setting, introducing interaction into there. And there have been interactive protocols for clustering that have been introduced. But there are a few problems with these previous works. So the first one is that typically these have been studied in isolation, which means that whenever you want to address a new setting, you have to come up with your new interactive protocol and your new algorithm, and that can be difficult to do. Additionally, most of these settings have required the user to answer every single question that's put in front of them, even when they're unsure, which can lead to noisy feedback. So in this work, we introduced this generic interactive learning protocol called interactive structure learning, and it proceeds as follows. The learner maintains some sort of model fit, and at each round, it presents the user with some data points, and this model fit to that subset of data points. And then the user looks at this substructure and provides some sort of correction to it. If there is one, or says no, everything looks good. So for example, in a clustering, it would look at this subclustering and say, no, these 2 points should not be clustered together. So there are a couple nice properties of this protocol. So the first one is that providing these snapshots provides context and hopefully elicits more accurate feedback. Additionally, by only requiring the user to provide partial correction, we also should hope to elicit more confident responses from the users. Finally, this framework is extremely generic. So it actually generalizes active learning and interactive clustering among other tasks. So addressing things at the interactive structure learning level actually leads to efficient algorithms in all of these settings as well. So formally, the approach that we take in this paper is to maintain a posterior distribution over structures. And at each round, we select some subset, show it to the user along with some structure drawn from our posterior distribution. We get some feedback from the user, and then for every structure, we update our posterior by downweighting those that are inconsistent with this feedback. And by only downweighting, we allow the user to provide possibly noisy responses. So the main algorithmic question that remains is, how do you go about choosing this subset? And in this work, we consider a generalization of the query by committee rule, which we call structural query by committee. And it has some properties associated. For example, we can show that under fairly minimal assumptions, if the user, under the user's feedback, that this algorithm is consistent. And under stronger assumptions, we can actually quantify this convergence rate. We also have some other results in the paper. For example, we consider a broader class of posterior updates to allow for efficient sampling from the posterior. And then we also look at kernelizing this querying rule, and we also present some simulations. If you're interested in learning more, please come see our poster, number 130, upstairs tonight.